So this is question 2 in the 2022 free response for BC. So the question says a particle is moving along a curve in the xy plane. Its position is x, d, y, t, and it moves in such a way that dx dt equals the square root of 1 plus t squared, and dy dt equals the ln of 2 plus t squared. And also at time t equals 4, the particle is at position 1, 5. So the first question is to find the slope of the line tangent to the path of the particle at t equals 4. So we're trying to find dy dx at times t equals 4. We know that's going to be equal to dy dt over dx dt at t equals 4, which is equal to the ln of 2 plus t squared all over square root of 1 plus t squared evaluated at t equals 4. And that is going to, if we just plug in, ln of 2 plus 4 squared all over the square root of 1 plus 4 squared. That is going to equal the ln of 18 over square root of 17, which is approximately 0.0701. So part B asks us to find the speed of the particle and the acceleration vector at t equals 4. So we know that the speed is equal to the square root of dy dt squared plus dx dt all squared. So the speed at t equals 4 is going to be equal to the square root of ln of 2 plus 4 squared all squared plus the square root of 1 plus 4 squared all squared no, it's not dt, it's just like that. And then that equals the square root of the ln of 18 squared plus 17, and that equals approximately 5.035. And then for the acceleration vector, we're going to have that acceleration vector equals, it's going to be x double prime of t, well, x double prime, it's at t equals 4, so x double prime of 4, comma, x double prime, y double prime, excuse me, of 4. And that equals, if we take the derivative of dx dt and dy dt and plug in 4, we get 0.970, comma, 0.444 for the acceleration vector. Now for part C, we have to find the y-coordinate. I'm just gonna zoom out. The y-coordinate of the particle's position at t equals 6. So to do that, we're given the initial point 1, 5 at t equals 4. So what we can do is do the integral from 4 to 6 of dy dt, which is the ln of 2 plus t squared dt, and we're going to add 5 to that because that's our initial condition, and that is going to equal, with our calculator 5 plus 6.571, which equals 11.571. And then this would be the y-coordinate of the particle at t equals 6. Now for part D, we have to find the total distance the particle travels from t equals 4 to t equals 6. So to do that, we're going to do the integral from 4 to 6 of the square root of dy dt squared plus dx dt squared dt, because this is the formula for path length, and this will give us a total distance traveled from 4 to 6, and that is going to equal the integral from 4 to 6, and we're just going to plug in dy and dy dt and dx dt. So the ln of 2 plus t squared all squared plus the square root of 1 plus t squared squared dt, and with our calculator that gives us 12.136 rounded up to 3 decimals, and that would be the total distance traveled for the particle, and that is the answer to the entire question.